Hello everyone, today we are going to look at question 2 of the 2018 organics paper. We are going to look at question 2 today, so let's get into it. Alright, so question 2, the first question asks about the structural formula of 2,3-dihydroxypropanol. Can exist as an enantiomer. So what it means in terms of having an enantiomer, it has what we call a chiral carbon. So it is a carbon that is bonded to 4 different groups of atoms. So this the carbon that I highlighted is bonded to 4 different groups. So that is different to the OH, which is different to the CH2OH, which is different to the COH. Okay, so it doesn't matter how you draw the enantiomer. So I'm just going to keep it the way they draw it. So I'm going to do CHO. If you want to copy it, it's fine. And I personally always do it like this. I just do, it doesn't matter with the lines which one you pick, but you do need to make sure that the first one is kind of like freeze drawing. You can draw it however you want, but the second one must be a mirror image of that. Okay, so I just decided to draw like this, and you can draw it differently, but you must have one line going up, one line going to the right, and then you have a dashed line and then a triangle shaded line. Okay, so that means you got 2 lines going in phase of the plane, and then you got one particular groups of molecule going into the computer screen or into your phone they're looking at. One is poking out of the phone. Okay, now to draw the mirror image, and this is where we have to go. This is a mirror, and this is when you need to draw the opposite. Okay, so it doesn't matter what you drew just now, it needs to look the opposite. Okay, so I should do CHO. Now the reason I do CHO is just remember, if it's an aldehyde, this is written as CHO. If you have, like, say, a CH2OH, then this is bonded to something else. This is CH2OH. Okay, just to differentiate the aldehydes and the alcohols. Now, so these OHs are going towards each other, and then my shaded triangle is going the other way. It's just H. And then the shaded part, which is the dash part, which is exactly the same as what I drew on the left hand side. Okay, so just remember the first one you can draw however you want. So like, say, and people go, if I'm looking at the marking schedule, it's drawn differently, it doesn't matter. But as long as the second one that you draw is a mirror image as the one on the left hand side, then it's all right. So why does this have exist as an enantiomer? This is because you have what we call a chiral carbon. Okay, so it has a chiral carbon or asymmetric carbon, but I tend to teach it as chiral carbon. This is bonded to 4. This is a carbon that's bonded to 4 different groups of atoms. Okay, so that's essentially why it can exist as enantiomers. If you want to go into more detail, you can say this allowed to form mirror images of each other. They're mirror images of each other. They're non-superimposable. The best example of enantiomers is look at your hands. Okay, so your left hands and right hands are identical to each other, but they're non-superimposable. So it means if you put one over the other, they won't completely overlap, but they are mirror images of each other. So the best way to, when I first started teaching enantiomers, I literally just say, all right, put your hands on the table and just look at your hands, and that's enantiomers right there. All right, next one. How could the 2 enantiomers be distinguished? So this is a very magical phrase that I tend to use. You shine polarized light through them. They will rotate the plane of polarized light in opposite direction. Okay, so I'm just going to jump straight into the answers. So here they are. So this is the first part. There's a chiral carbon, 4 different groups. they can be distinguished upon the ability to rotate the plane of polarized light. Okay, so just memorize one enantiomer will rotate clockwise, and the other one goes anti-clockwise, but they rotate the plane of polarized light. Okay, so the plane of polarized light. And if you don't do physics, I'll just give you a really simple explanation. You can look it up on YouTube. There are plenty of animations that you can find. The best way to use in terms of example, you can think of sunglasses, especially when they say the sunglasses, the lenses are polarized. So what it means, it filters a particular wavelength and it only lets in a certain amount of light. And if you you can think of it as regulated lights, because light goes in all sorts of directions, and the plane, when you polarize it, that means only a certain direction of the light waves can come through. And if you shine that regulated light through the solution, they will be rotated oppositely depending on which enantiomers you have. Okay, so very straightforward. Let's move on. Dipeptide, so this is looking at dipeptide made of 2 amino acids. Okay, so that's when you have we need to first circle the amide group. So this is a CON right here, CON, and you can include the H as well, but the CON is absolutely essential. That's where your that's where your peptide link is. Okay, so compare and contrast the acidic or basic hydrolysis. Okay, so this is hydrolysis. So before we even look at this particular question, let's just look at hydrolysis first. So hydrolysis is using water to break this particular polymer, to break this dipeptide link. And this is the one thing I've always said to my students. If you see oops, let's do a single bond. If you see COO, or if you see CON, let's say if this O is bonding to another C, this N is bonding to another C, can you just remember, whenever you're trying to do hydrolysis, always look for the COO or the CON thing, and then you draw a line between the single bonded CO or the single bonded CN. Okay, that's absolutely essential. Polymerization can be extremely confusing. I mean, this particular molecule is not too bad, it's not too big, but I can give you a really long chain protein and then ask you to do hydrolysis. All I'm actually doing is just adding more things you need to copy. It doesn't increase the difficulty if you know what you're doing. So if we look at this particular question, let's get rid of the box. If you see that CON, you will just need to get a pencil, get a pen, just cut between the C and N single bond. And what that does, let me get rid of these as well. What you then need to do is a basic thing called copy paste. So let's start copy pasting. So on the left hand side, I have H2N, CH2, CO. See, I didn't do anything special, I just copied it. And on the right hand side, I'm going to copy NH, CH, CH3, COOH. Now for your convenience, I didn't even change the way the bonds are arranged. Okay, I just break it off the middle and then I copied and pasted. Now obviously this is incomplete. I mean, if you have any sense of chemistry, this looks way off. Okay, so what happens is that this obviously needs an OH and this needs an H, and the question is, where did the H and OH come from? And this is what hydrolysis comes in. Hydro is to do with water, and what is water made of? Water is made of OH and H. So the H and OH are added into the two separate smaller molecules to make them stable, and hence breaking the peptide. So whenever you're trying to think about it doesn't matter what type of question. So this is what I meant. I could literally add, like say, instead of NH2, I can change this to, like say, adding more things on the left hand side. It doesn't matter, you're just copying it. You're only looking for the CON, you cleave it in the middle, cut it, copy left, copy right, and then just complete the end the OH always goes to the CO double bond because this is your carboxylic acid, and the hydrogen always goes to the nitrogen, which gives you the amine group. Okay, so that's absolute fundamental. If you understood that, you can do any hydrolysis or polymerization question at year 13. It is that easy, because sometimes they can give you ring structures, and that throw people off. Like, I don't understand rings. I never learned rings. I don't know what to do. Just cut, copy, paste. Okay, and then complete. So that's your 4 C's. All right. So cut, copy, and then complete. Sorry, 3 C's. Okay, just remember the 3 C's. You cut the thing, you copy it, and then you complete it. Now you understand the basics. Now we can do a little bit more. So these two are the base structures. So these are the 2 amino acids, and if you didn't know what amino acids are, this is an amine. The COOH is a carboxylic acid, hence amino acid. This is NH2, which is amine. This is COOH, which is acid, which is why it's carboxylic acid. The NH2 part is actually alkaline or basic. The right hand side is a carboxylic acid, which is acidic. Now, if you do hydrolysis in acid or base condition, so it says acidic or basic condition, so it doesn't matter which one you do, you will always break the dipeptide into these 2 things that we draw over here. Okay, but then if you do acidic condition, you then need to understand the amine part of the monomer will then further react. So what it means is that the base part of the molecule will gain another hydrogen, because that's what bases do. So this is acidic condition. So they will always do the this part first. You always make these 2 small molecules, and then you just need to do 1 extra step. Okay, same with the other thing. You gain another hydrogen, and then in turn the nitrogen becomes positively charged because you gained another positive ion. The rest doesn't change. Okay, now if you do this in basic or alkaline condition, then you will need to apply the thinking, because now the left hand side doesn't do anything anymore because it is alkaline. Alkaline doesn't react with alkaline. On this side, you lost this hydrogen because when you reacting acid with a base, you neutralize, you give away a hydrogen. So the 2 products that you will produce, are going to be these COO minus. Okay, so these two are your basic condition products, and then the other 2 are your acidic condition products. Okay, so that's on the basics that you can, do the 3 C's. You can cut, copy, and complete. And then once you wrote them down, you just need to think about, okay, look at the thing you've drawn and imagine if that thing is being put in an acid or base condition. Is it going to further neutralize? Is it going to further react? And if that does, and you can recognize it, and then you can explain it, then that's an excellence. Okay, so let's have a look at the answers. So what is used? So that's what hydrolysis is. You break the peptide, and then you have H is added, OH is added. See, so the NH2 groups gains of H plus in acidic condition, neutralization. The COOH lose a proton in basic condition, neutralization. Okay, so it's not really tricky, and those are your molecules there. Just remember, it doesn't. You can try my method as many times as you want. It will work all the time in NCEA level 3. All right, last one. So this is structural formula of butanol, and devise a reaction scheme. Oh, I love the questions like these. To convert butanol into butanone. So you're trying to convert butanol into. Now, when I do questions like these, guys, I tend to be quite lazy. I don't include the hydrogens because it just takes too much time. All right, so I'm starting off with this. So first thing first, this is an aldehyde, this is a ketone. The only way to make a ketone, so I'm not going to make it go around. The only way to make a ketone is to have a secondary alcohol. There's no other way in year 13 organic chemistry in NCEA that there's no other way. So you have to have this. There's no other way of making ketone from NCEA level 3. So how do we convert that? So we go either Cr2O72 minus acidified, and that's going to give us the ketone. And this is a thing that I would encourage you to do with flowchart questions. Don't just keep thinking you have to go forward. Sometimes you can work backwards. How do you get the ketone? You have to start with the alcohol. Now, we have an aldehyde. Now let's go back here. So you have an aldehyde. The aldehyde can further oxidize to carboxylic acid, which is not very useful because we need to convert whatever this is into something similar to this secondary alcohol. The only thing here is that you work backwards. You use sodium borohydride and ABH4 undergo a reduction reaction. When you undergo reduction reaction, you make butane 1-ol. So how do I convert butane 1-ol to butane 2-ol? So how do I do that? Well, you can't just do that straight away. You have to go around. Now, the easiest way, so you have to work backwards from your flowchart. This is where you are going to use H2SO4, and then you will make CCC, you will make an alkene. And then can you see from the alkene, I can add diluted H2SO4, and then I'm going to get two products. So I'll either get CCCCOH, or, well, not or, it's an and, CCCCOH. Okay, so this is CH2. Let me just complete this if you can't see it straight away. So this is addition reaction, rich gets richer. So this carbon has more hydrogen. So this is, so when the hydrogen gets here, this is a major product, and this is a minor product. And can you see we have our secondary alcohol, which is exactly the same as that. And then you just go acidified dichromate, and then that will give you the thing. Okay, you don't have to go to the alcohol. I suppose you can further, if you want to convert the butane 1-ol, like say you want to convert this into a haloalkane, the haloalkane into a alkene, it doesn't really matter. There are quite a few methods, but this is the easiest one. Okay, so this just a really good example when I say to my students, you have to know your flowchart to do well, but it doesn't mean if you memorize a flowchart you're guaranteed success, because you need to know how to use it. So you need to be smart about it, all right? Because so think in this particular way. So this is the first step that we kind of did, and then that kind of set the tone for the rest, because you essentially need to get to the secondary alcohol. And how do you get the secondary alcohol? And then if you look back at your flowchart, then you can think about, you know, the addition reaction, the elimination reaction, and then that's how you get there. Okay, so hopefully this video has been helpful for you. Smash the like button and subscribe if you haven't, and I'll see you guys later for question 3. Bye bye.